Welcome to my problem number 2, week 5 video explainer. So in this example, we are given a pendulum system that consists of a massless rigid rod and a sphere that is connected to the end of it with mass m and radius r. And just it's denoted in this diagram over here. And for this first part of the problem, we are supposed to find the moment of inertia of the pendulum about the pivot point. And we are also given the moment of inertia of the solid sphere, which is 2/5 mr squared. So we know that we can find the moment of inertia of the pendulum about the pivot through the parallel axis theorem, which is that inertia value is going to be given by the inertia of the center of mass plus the mass times that distance squared. And in this case, that distance from the center of mass to the pivot point is going to be L. So just substituting that value for the sphere and L for the distance, we can factor out the mass and we find that inertia value. And for the second part of the problem, we are trying to find the torque on the pendulum if it is displaced from vertical by an angle theta. So we know just that the torque can be calculated through mg L sine theta as given through that first equation. And also, I just quickly to note that I just drew a diagram over here on the right that denotes the forces acting in this system. And this last part, we are trying to find out the angular frequency for small displacements and whether or not it is dependent on the mass. So we can find that the angular frequency is equal to the square root of the mass times gravitational acceleration times that length or distance L over the mass times the moment of inertia for that center of mass value. And we can see that those masses ultimately end up canceling out, and we find that value for the angular frequency is equal to g times L over 2/5 r squared plus that distance L squared. And this problem just relates to more stuff about oscillations, angular frequency, and the parts I found tricky about this in particular were the second problem in trying to find the torque and trying to figure out all the forces and components of that problem. And also something that was a little more tricky was just interpreting the parallel axis theorem and understanding it conceptually. And otherwise, yeah, thank you.